students. Oh, hello, algebra students. Sorry if I repeated myself. I wasn't sure if it started recording. Anyway, we're going to get a little more practice with absolute value inequalities. The first two are pretty straightforward. The next two are a little bit tricky. But why don't you try these first two on your own, pause the video, and see what you can do with them. See if you get them right. Okay, hopefully you've tried them on your own, and here comes my solution. 4x minus 3 greater than 10, or, because it's a great or, and then I get 4x minus 3 less than negative 10. So now I add 3 to both sides, and I get 4x greater than 13, or, okay, and I get 4x less than negative 7. Got to get x alone, so I'll divide by 4, both places, divide by 4 there, divide by 4 there, and that will give me that x is going to be greater than 3 1/4, excuse me, or x will be less than negative 1 3/4. That's pretty straightforward. I can make a number line and get negative 1 3/4, and I need to show 3 1/4. Okay, so I do an open circle, open point on both of those. It's an or, so I'm pretty sure they're going to shade this way, but just to double check myself, the number is greater than 3 1/4. Yeah, they're to the right. And then I need a numbers less than 1, negative 1 3/4, and those would be to the left. All right, here comes my solution for number 2, 3x minus 1 less than 7, and 3x minus 1 greater than negative 7. Adding 1, I get 3x is less than 7. Divide by 3, divide by 3. X will be less than 2 1/3. Okay, this is an and problem, yes. Confused myself. Need to add 1, and I'm going to get 3x greater than negative 6. Dividing by 3 on both sides gives me the solution that x is greater than negative 2. So we need x to be greater than negative 2 and less than 2 1/3. And on a number line, we got a negative 2 there, positive 2 1/3 there. They're both going to be open points because it doesn't say equals. And I will shade in between. Okay, now 3 and 4 are a little bit strange. I actually know their answers, and they're very, very simple. But I'm going to do them the long way, just like I would all the other ones, and I'm going to show you what happens. But I already know what's going to happen, and I can get the solution with like almost no work. Okay, and this is an and statement, right? Okay, and I subtract 3. 2x is less than negative 4. So I'm going to divide by 2. So I'm going to x is less than negative 2. Now over here, I'm going to subtract 3. And I'm going to get 2x greater than negative 2. I'll divide by 2. And I'm going to get x is greater than negative 1. Now let me ask you this. On a number line, I'm going to have a negative 2. I'm going to have a negative 1. Is it possible for me to have a number less than negative 2 and greater than negative 1 at the same time? No, it's not. This problem has no solution. I'll repeat that. Because there is no number that's less than negative 2 and greater than negative 1 at the same time, this has no solution. So I actually knew that right from here. I know that distances have to be positive, and I got a distance less than a negative value. I know that that's not possible. So this has no solution. I could have said no solution right from the get-go. All right, so let's check out problem number 4 here. And again, I'll do my little tree root thing, and I'll get 5x plus 1 greater than negative 3. And then I'm going to get 5x plus 1 less than negative 3. Oh, positive 3, excuse me. And that's an OR statement. So I'll subtract 1, subtract 1. 5x greater than negative 4. Divide by 5, divide by 5. So I need x is greater than negative 4/5. And it's an OR problem. I'll subtract 1. I'll subtract 1. I'm going to get 5x less than 2 dividing by 5 will get me x is less than 2/5. Now, are there numbers that are greater than negative 4/5? Of course there are. Negative 4/5. Sorry. Those numbers would all be this way, wouldn't they? And are there numbers less than 2/5? Yeah, well, 2/5 would be approximately here. And open circle. And those numbers would be this way. So this is a situation where every single number on the number line is a solution. So the solution to this is all real numbers. Yeah, and again, this is one where I could have told you the answer just by looking here. My distance was going to be greater than negative 3. Distances are never negative. They're always 0 or positive. And since 0 and positives are all greater than negative 3, then all real numbers will fit. Any number I put in for x will get me a true statement out. All right, that's the lesson for today. I will say good night, everybody.